Welcome to Introduction to C Programming. Today we are going to talk about recursion and how it relates to iteration. So far we have learned about different looping structures such as the while loop, do while loop, and for loop. Each time the body of a loop executes, that is called an iteration. However, loops are not the only way that we have to execute the same code more than once. We also have functions that we've just recently learned, so we can call a function more than once from another function, and this is a way that we can have the same section of code execute more than once. Each time would be known as an iteration. So looking at the code sample that I have down on the bottom of that screen, you see that on line 4 I'm calling the function myFunction. It's actually going to get called 10 times on that line, and then I also call it again on line 6, 7, and 8. So this is actually going to call the function myFunction 13 times in this code. Here is just an example calling functions, so let's walk through this and see what we get. So we start off in the main function on line 10. Line 11, we set the value of the num variable equal to 3. Let me go ahead and draw up main memory here on the board so that we can see exactly what's happening. Okay, so here is my heap. I have the num variable, which is part of the main function, which is going to point to some location inside of main memory, and it gets the value 3 on line 11. Okay, I made that a little bit bigger, so hopefully you can see that better now. Okay, on line 12 I call the function func1. I pass num into it. Now you see func1 on line 2 has a variable num inside of it also. Now remember that that variable is in a completely different scope than the num variable which is in the main function. So on my heap I will have my variable num, which is part of func1, pointing at a completely different location in memory, and it is just going to have the value copied into it. So I get a 3 copied into that location in memory. On line 3, I increment the value of num. I add a value to it. I add 1 to my variable num. Well, the variable num that I have access to on line 3 is the one that was declared inside of the function func1. So this variable now becomes a 4. Now you notice that it did not change the value of the num variable, which was in the main function. So when I print out the value on line 4 of the variable num, it's printing out the one which is within scope, and that's the one that is on that was declared on line 2 in func1. So it's going to print out the value 4. So I'll just keep a little running tally over here of what's printed. It's going to print out a 4. Then I come down, I return from that function, I come back down to line 13, and I increment the value of num. Well, which variable num am I referring to on line 13? It's the one which is within scope, which is the one in the main function. So it's going to increment the value of num in the main function to now be a 4. Now let me go back one step. On line 12, after func1 terminates, I actually lose my reference into main memory of that variable. So I lose that pointer into main memory because the variable num in the function func1 has gone out of scope. I have no way to access that variable anymore. Once it goes out of scope, I lose my pointer from the heap coming into main memory. Okay, so back down. So line 13, I incremented the value of the num variable that was declared inside of the main function. I incremented it to be a 4. Line 14, I call func1 again. I pass in num. So now I have this func1.num, and it's pointing at some location in memory, probably a different one. It's a different function call. And inside of that location, I'm going to get the value of num from my main function copied into it. Then on line 3, I increment the value of num. That's going to increment the value of num in the variable that was declared inside of func1. So it increments this one from a 4 to a 5. It prints that out on line 4. It prints out the value 5. I return from func1, so I lose this pointer into main memory. I go to line 15 in my main function. I increment the value of num. Which variable num is that? That's the one that was declared in the main function. I increment that one to be a 5. Then I call func2, passing in num. Now func2 has a variable num that was declared on line 6. So now I'm going to have another variable called num declared in func2 pointing at some location in main memory. The initial value of that variable is the one that was passed in. On line 16, I passed in the value of the num variable in the main function, which is a 5. I pass that into the function. I get a 5 to start. On line 7, I say num plus equals 2. It's going to increment the value of num by 2. So now it's going to take this 5 and it's going to make it a 7. On line 8, I print out the value of num. It prints out a 7. I return from that function, so I lose the pointer to that location in main memory, and my program terminates since that's the last line of code inside of my main function. So you can see how the different scopes definitely affect the variables. I had all of the variables in this program were named num. However, each one was declared within a different scope. And so when I was changing the value of the variable, it might not have been changing it in the function that called it. It was only changing it in the function that was called. Make sure that you review this. This is an important slide. It's going to be important that you understand scoping issues, because we're going to, in the future, in one of the future lectures, we're going to talk about different ways that we pass variables into functions, and we're going to talk about different scopes of variables. So this is very important that you try to understand already how the different variable scopes work if we pass variables into functions, and if we declare them within functions, who has access to those variables. Okay, moving on now to today's topic of recursion. The way that recursion works, so we've seen that we have had a function which is able to call another function. However, we can also have a function call itself. When a function calls itself in the body of the function, either directly or indirectly, this is called recursion. So look at the example that I have here. So line 1, I declare a function called myFunction. Inside, you see on line 5, I'm actually calling that same function. I'm calling myFunction right there. Now you might think, this makes no sense. This is going to be an infinite loop. It's just a function calls itself, which calls itself, which calls itself, which calls itself, and it's going to loop forever. And you actually are correct if you don't have some kind of a stop condition. You have to make sure that you always have some condition which is going to break you out of this recursive cycle. In this case, you see that I have an if statement there. It says, if num is greater than 0, then I'm going to do that stuff. If the value of num becomes 0 or is less than 0, it's not going to call the recursive function. And you see that my variable num is being decremented here on line 4 each time that I come into this function. So that tells you that eventually I am going to reach that stop condition. So recursive functions, you have to look at them a little bit closer than you do the other functions to make sure that you always have that stop condition. It's very important that you have a stop condition anytime that you have recursion. That's the first thing that you should think about when you think about a recursive function. What is the stop condition? Okay, so looking here, what I'm doing is I'm going to print out the value of that variable num. I decrement num, I call that function again, and then you see that I print out the value of num again. So what I'm going to do is I'm going to walk through this code with you, and we can see what's going to happen when we call the function on line 10. So let's assume we have the main function, and then we call the function myFunction with a value of 3 on line 10, and let's see what gets output. Okay, so I start off and I call myFunction with a value of 3. So I'm going to write up here that I call the function myFunction with a value of 3 passed into it. Okay, now when I come into my function, the first thing that it says is, what's the value of num? Well, the value of num at this point is 3. If 3 is greater than 0, it is. So what am I going to do? I'm going to print out a 3. So I'm going to write over here, I printed out a 3. Okay, I decrement the value of num, which makes it a 2 now. And then I call myFunction on 2. So from this call to myFunction with a value of 3, I now am going to call myFunction with the value of 2 passed into it. Okay, so what I've done is, actually let me rewrite this here so we can follow along exactly what's happening. So I started off and I printed 3, and then I made num equal 2, and then I called myFunction. I passed in the value 2. Now, I still have one more line, which I'm going to print out a 2, right? I'm going to print out a 2. However, I have to now execute my function passing in 2 before I can get to that. So when I call my function with a 2, it's going to say is 2 greater than 0, and it is, and then it prints out a 2. So right here, I'm going to do a print 2. Okay, I decrement num now to be a 1, and then I call my function passing in a 1. Now, it's going to print out a 1 still. However, I have to now execute my function with a 1. So when I execute my function with a 1, it says if 1 is greater than 0, it is. Now it's going to print out a 1. It's going to decrement num now to be a 0, and then it's going to call my function passing in a 0. Now when it calls my function passing in a 0, it says 0 is not greater than 0. It breaks out of the if statement. So that if statement is not going to execute. There's no other lines of code inside of that function. So then it's just going to say, okay, what's the next line of code after I called my function with a 0? Well, the next line is that I was going to print out a 0. Okay, and then that function, so now this function and my function passing in a 1 terminates. So now, when I called my function passing in a 2, it printed 2, it set num equal to 1, it called my function with 1. Now that that's done, it goes to the next line, which is, well, let's print out a 1. And then that function terminates. Now when I called my function passing in a 3, it said print 3, change num to be 2, call my function of 2, which just terminated. The next line says print out a 2. So now on that line, actually I needed to indent this one a little bit here. So this one lines up there. So I'm going to print out a 1. And now here is where I'm going to print out a 2. And then that function terminates, and then my program is done. So what I've actually printed out now is 321012. Pretty cool, huh? So I printed that out using Recursion with how it was going to, just because of how Recursion works. Okay, so as you see from this example, recursion is not an easy problem. It's not easy, even when you have a function that uses recursion, to really walk through it and figure out exactly what it's doing. There are certain types of problems that are recursive problems, and we'll see a few of them today. And you should never try to just use recursion because you like it. You should find what the format of the problem is and then see if it's a candidate for recursion, and then figure out whether or not you should use recursion or use iteration for it. So, just a little description of recursive functions. These are called to solve specific problems. They only know how to solve a very, very simple case, which is called the base case. If the recursive function is called with a value that is not the base case, then it's going to divide the problem into two conceptual pieces. One is the piece the function knows how to do. The other is the piece the function does not know how to do. However, that piece needs to resemble the original problem enough so that recursion is feasible. And that means that what we're going to do is call ourselves just with a different value passed in as one of the variables. And those are going to be your algorithms that are candidates for recursion. So let's take a look here at some of the more famous recursive algorithms that we have. So what we need to be able to do is to define a subproblem that looks very, very similar to the original problem. If we can do that, then we have ourselves a candidate for recursion. Let's take a look at factorials and see how that works. So with factorials, we have 5 factorial is equal to 5 times 4 times 3 times 2 times 1. Now, 4 factorial is 4 times 3 times 2 times 1. What you can notice here is that we can rewrite 5 factorial as 5 times 4 factorial. What we've done is we've reduced our problem to a part that we know how to solve, which is the multiplication, and a part that we don't know how to solve, which is the factorial. So we know how to multiply some value by 5. What we don't know is how do we solve 4 factorial? Well, we can just continue recursing until we get down to a point that we know how to solve something. What's the problem that we know how to solve? Well, we need to figure out what our base case is going to be. Our base case for factorial is probably going to be that we know what 1 factorial and 0 factorial both are. These are both defined. They're accepted that they both equal 1. So when we get down to that point, we know that 1 factorial and 0 factorial are both 1. So we say if the number that's passed into our recursive function is equal to 1 or equal to 0, then we just return a 1. We know that the value of 1 factorial and 0 factorial are both equal to 1. And then otherwise, what we're going to do is we are going to say that the answer is going to be whatever our number is times the factorial of 1 less than that number. So this is actually a very, very small problem to write. It doesn't even take that many lines of code to write this problem out. Okay, so that's going to wrap it up for recursion today. There are some other recursive algorithms. The Fibonacci sequence is another good recursive problem. That would be the sequence of the numbers 1, 1, 2, 3, 5, 8, 13, 21, and so on, where each subsequent number is the sum of the previous two numbers. This is also a recursive algorithm. You can find the code for that in the book. You can also find it online. And you might want to just think about it, see if you can figure out what the recursion is, and maybe write it yourself. What we're going to do is this program here, the factorial program, we are going to write this. You are going to see the code, and it is going to be posted on the site. So you'll see that for the program for today's lecture. Okay, if you have any questions, let me know. Good luck.